Okay, let's give you guys some practice. So evaluate this. So evaluate this. Work out this area here. Okay, so work out this area here. So press pause and have a go. Okay, so to evaluate this here, you have to integrate this, meaning you have to search for something that when you differentiate it, it will give you this thing here. Well, when you integrate this, it should be inverse tan of x, and you must know this. When you differentiate this, it will give you this because hang on. So remember, you must already know this. If y equals tan of theta, then when you differentiate it, blah blah blah, using the product rule here, it should be blah blah blah, and when you differentiate it, it will give you this. So remember, at the moment we are just differentiating the normal tan, not the inverse tan. Okay, not the inverse tan. We are just differentiating the normal tan. Or differentiating the normal tan would give you this, and you must already know this. You have to memorize this. Okay, and then once you know this, we can then use this to differentiate this. So what I'm trying to show you is that when you differentiate this, it will give you 1 over x squared plus 1. Okay, so anyway, knowing this, let's try and differentiate this. So remember, all this you should already know. Here you've got to tan equally to both sides. That will then take you to this, and then use implicit differentiation. That will then take you to here, and then here you've got one block multiplying with another block. So get rid of this one here. So when you get to this stage here, imagine this as multiplying to the top. So you've got this thing here, dy by dx here. So to kill off this thing here, times both sides by cos squared of y. That will then take you to here, and then now you don't really want the answer in terms of y here. So you would go back to this stage here, and remember we've done all this before here. You would go back to this stage here. So once you're here, you don't want the answer in terms of y. So you would go back to this stage here, and then look at this. Create a scenario where this here is true, where this is true. Well, tan of y is this. Okay, so you've got an angle of y here. Tan of y, well, you would create something that's true. So you would say x. So you would call this side, let's give it a name. We would call it x. Let's give this thing, let's create it in such a way that this thing here is true. Well, the way you would create this thing to be true would be to make this length here to be x and this length here to be 1. Okay, well, if this is x, this is 1, then this length here, by using Pythagoras, must be this. So cos of y translates to blah blah blah. We've done all this before, so it should be blah blah blah. It should give you this. Okay, and you must already, you have to ingrain this in your mind. Okay, so well, the point I'm trying to make here is that when you differentiate the inverse tan of x, when you differentiate this, it will give you this. Okay, so when you integrate this, it will be this. So now you've got to evaluate it. This, so this, take away this thing here, will give you this. So the overall answer, the area, is given by this. Okay.